When you think of plants, you might not think of them as being very good at moving. Plants are sessile by nature, and they kind of have to cope with whatever conditions they find themselves in. But plants are actually really good at moving, just not in the way that you might think. In the face of things like climate change and habitat fragmentation, plants can either move somewhere else, they can adapt to their current environment, or they just die. So, of course, seed dispersal, which is how plants move, is crucial for the survival of plants. Plants can move in a number of different ways, including things like sticking to an animal's fur. They can move through the wind. But the actual mechanics guiding how seeds move, on a fine scale especially, are relatively unknown to plant ecologists. That's why I focus my research on fine-scale seed dispersal and how plants move in Pacific Northwest prairies, specifically the Whetstone Savanna Preserve down in southern Oregon near Medford. This is a relatively small prairie. It's only about 400 by 400 meters, and it's characterized by 3 distinct habitat types. These habitats, as you can see up here, are bushes, hummocks of just bare prairie, and vernal pools. I'm predicting that these different habitat types will confer different challenges for seed dispersal in this prairie. The species that I'm investigating in this prairie is called Plagiobothris nothofulvus, or rusty popcorn flower. You can see it right here. It's this cute little white flower. And it only lives on the hummocks in this prairie, which makes for a really interesting sampling scheme in this experiment, because I can isolate the influence of these different habitat types on dispersal ability by separating my sampling sites by specific landscape features. So, unfortunately, seed dispersal is almost impossible to directly observe, so instead we rely on genetic methods to parse out these kinds of dispersal events. So when I'm sampling my sites, I'll get a genetic distance between 2 different sites, separated by a specific landscape feature. So if 2 sites are really genetically dissimilar, you can assume that the landscape feature between them is a really big challenge for seed dispersal, because obviously not a whole lot of seeds are getting across there. So this genetic distance that I'm finding, I'll use it to inform a larger dispersal model for the entire prairie to hopefully shed some light on the mechanics of seed dispersal. With a program called CircuitScape, which, as the name implies, uses circuit theory to generate a dispersal model, I can kind of make these predictions. So you can think of electricity running through a circuit like seeds moving across a landscape, finding the least cost path based on these different landscape features. So this program will assign resistance values to each of these 3 habitat types and generate a dispersal model for the entire prairie, which will hopefully kind of give me some information about fine-scale seed dispersal, how it works, and maybe if a seed can travel across a vernal pool, it can travel across larger, more unfamiliar habitats in the face of climate change and fragmentation. Thank you.